Okay, so we've been finding equations of secant lines, the line through 2 points, for many semesters, all the way from beginning algebra, intermediate algebra, and college algebra. Finding an equation of a line, hopefully not too difficult for you, but it's about to get really difficult conceptually. And it's called a tangent line. So the tangent line of a graph at a point xy is the line that best approximates the slope of the graph at that point. We are now trying to find the equation of a line called the tangent line, which is the line that represents the slope of the graph at that point. We're trying to find the equation of that line. Now remember, to find an equation of a line, you need two things. You need a point, which we have, but you need a slope. Well, now we're going to start having some issues, because to find a slope, you need 2 points. But we're no longer given 2 points. We're only given 1 point. So how can you do y2 minus y1 over x2 minus x1 if you're not given 2 points? How can we find the slope of a graph at a single point? And that's a very difficult conceptual concept that we can wrap our heads around using some calculus techniques that we already learned in previous sections. But let's go ahead and do it graphically. So let's look at example 2 here. It says, use the following picture to approximate the slope of the graph of f of x equals x cubed at the point 1, 1, and then determine the equation of the tangent line in slope-intercept form. So what you see here is the black line is the graph of x cubed. This is the standard graph of x cubed. Here's the point 1, 1, and if you see this gray dotted line right here, that is the tangent line, which is the line that touches at the point 1, 1, goes through the point 1, 1, the desired point, and the slope of that line is the slope of the graph at that point. So that's what the tangent line is. Goes through that point, and the slope of the gray line is the same as the slope of the black line at that point. Okay? So the question then becomes, what is the equation of that line? Well, again, we need to know the point. We know the point. The point is the point 1, 1. But we also need to know the slope. When you know the slope in the point, you're going to plug it into y minus y1 equals m times x minus x1. So the question becomes, how do we find the slope if we're not given 2 points? Well, visually, we're able to do it on this problem right here. We see the point 1, 1. All we need to do is find another point that's on the gray line. Because there's a nice grid here, we can see another point. I'm looking here, and it looks like this is the point, what, 2, 4? 2, 4 would be another point on that gray line. So that allows us to find the slope of the line. If I want to find that slope of the line, again, I do y2 minus y1 over x2 minus x1. But in this case, it would be the first y value, which is 4, minus the second y value, which is 1, over the first x value, which is 2, minus the second x value, which is 1. Again, make sure that your x and y's line up in pairs. So it looks to me like we're getting, what, 3 over 1, which is 3. So the slope of that gray line is 3. Okay, so that gray line being the tangent line again. The slope of the tangent line is 3. So now we have a point, 1, 1. We have a slope, which is 3. Now we can plug it into the point slope form. So this would be y minus, well, our point was 1, y value is 1. Our m value is 3. And then x minus, well, the x value again is a 1. Let's go ahead and distribute that 3 to both terms. I'd end up with y minus 1 equals 3x, and then 3 times negative 1 would be that minus 3. I add 1 to both sides. When I add 1 to both sides, I'm ending up with y equals 3x minus 2. So what's the equation of that tangent line? Well, only because we were able to find a second point using that grid, and we were given the graph, we know that the answer is 3x minus 2. Y equals 3x minus 2. Okay? So the big question then becomes, how would have we done it if we weren't given the graph? If we weren't given the graph, what would we do? How would we find that second point? How can we do this? Okay? So this next part is very, very difficult to read through. I'm going to start reading it for you from here, but the main explanation is going to be on the next page. You really have to absorb the next page and a half to 2 pages of notes to understand what the heck's going on and what the heck are we going to be doing. I'm going to draw you a little picture to get you started to see what's going on with this. Okay? So I'm going to have 2 points. I'm going to call my first point x, and then I'm going to call my second point whatever x is plus a little bit. And I'm going to call it x plus h. And what this textbook likes to use is it uses x plus delta x. I don't want to use delta x because to me that gets too complicated. Okay, so what's going to happen? We want to find the slope of the secant line through these 2 points. The slope of the secant line. So if I was finding the slope of that secant line, it would be, well, we need to consider what are these points as ordered pairs. Okay, if this is the function f of x, if I'm given an x value, how do I find the y value? For instance, if I'm given x equals 2, how do I find the y value? Well, I simply just plug that value into the function. So I just plug 2 into the function and I'd see what it gets. So if I'm given x, how do I find the y value? I'd just plug in that x value. If I'm given x plus h, how would I find that y value? Well, I'd do f of x plus h. So those are what my ordered pair would be. Take those x values and throw them in. So this is the value x, this is the value x plus h, and I want to note that the distance between the two of these we're calling h. The distance between the two of these is h, whatever h may be. Okay, so let's look at this. Again, to find the slope, I need the change in y's. Well, my one y value is f of x plus h, that's my second y value, minus my first value is f of x. On bottom, my second x value was x plus h, minus my first value, which was x. I'm going to do some simplification. Not much I can do in the numerator because I don't know what those values are. That's f of x plus h minus f of x all over, well, the x's would cancel out and I'd be left with h. So how do I find the slope of a secant line? I do f of x plus h minus f of x all over h. And I ask you, does that seem familiar? Have you seen this before? And the answer should be, if you did the lines and functions review, the answer should be yes, you have seen this before. This was something that we evaluated on one of the problems. I called it the difference quotient, and I said it's very important. You're going to see this again very, very soon. So how do I find the slope of a line between any 2 points? Well, in particular, the points x and x plus h. I would do f of x plus h minus f of x all over h. Now remember, this is just the slope of that line. I am just finding the slope of that line. But the question then becomes, how do I find the slope of a line at one point? So here's the cool trick. Here's what we're going to do. We're going to take the line through these 2 points, but then we're going to move this second point closer and closer and closer and closer to the first point until the 2 points are infinitely close to one another. Infinitely close. So we can find the slope of the line through 2 points that are infinitely close to each other. Okay, so if I'm moving these 2 points closer and closer together, I need you to analyze or think about this. What did I say the distance between these 2 points were? Well, we said the distance between these 2 points was h. So if I move these 2 points closer and closer together, what's happening to the value of h? Well, h, the distance between them, would be getting smaller and smaller and smaller and smaller. In fact, I said I want to move these points infinitely close, so that means h would be getting infinitely closer to the number 0. So as these 2 points move closer together, h moves closer to 0. So how would I find the slope of a tangent line? Hopefully this is triggering something for you. How would I find the slope of a tangent line? Well, it's the exact same thing, the slope of the secant line, the slope between the 2 points, but I need h to get smaller and smaller and smaller. And the way that I'm going to do that is by working off of what I did in a previous section, limits. I want h to approach 0, so I want to look at the limit as h approaches 0 of f of x plus h minus f of x all over h. This is how you find the slope of a tangent line. Now in our textbook, it's going to look a little more difficult than this. Instead of using h's, they use those delta x's. Delta x would just be the change in x. Delta x here is our h. So this is, looking at that picture, we used h, they just call it delta x. I don't like to use delta x. I think it's a little more complicated, a little more confusing for the students. I personally have always used h's to help it clean up. But that's the only difference. Instead of x plus h, they have x plus delta x. Delta x. Instead of f of x plus h, they have x plus delta x. So that's essentially the rough of what's going on in this whole next page or two of notes. It talks about, okay, well, we can't find the slope at 1 point, so we need to find the slope through 2 points. Let's find the points through those 2 points, x and x plus h, and then just make h smaller and smaller and smaller. So how do we find the slope of a tangent line? How do we find the slope of a graph at 1 point? Well, we don't. We find the slope of the graph between 2 points, and we just move those points closer and closer and closer together. So slope of the secant line is the difference quotient. The slope of the tangent line is the difference quotient, but then you look at the limit as h approaches 0.